This is a video for AQA Further Pure Mathematics, Calculus section 5.1, where we're looking at integration techniques using arc sin x. Well, you may have seen in previous videos how we can use this standard integral for integrals where we've got 1 over the square root of a squared minus x squared. And that comes to arc sin x over a. Now remember that arc sin can also be written as sine minus 1 of x over a plus c for this particular integral. I want to consider a slightly more complex integral here where the square root on the denominator is not exactly of the form a squared minus x squared. So we can't directly use this formula. However, we can, by doing some manipulation of the denominator, work out an expression which is in the form a squared minus x squared. So that's what I want to do in the next few slides. The question then asks us to show that the integral that we've been given can be written in the form 13 over root 2, and then an integral where you can see that the denominator is almost anyway of the form square root of a squared minus x squared. So we'll be able to then easily use our standard integral. The first step then is to take the integral that we've been given, 13 over the square root of 7 plus 4x minus 2x squared dx, and take out the factor 13 from the numerator and a factor of 2 out of the square root. So that's where the 13 and the square root of 2 comes from. Inside the integral we'll then be left with 1, and the denominator will now be, remember when we take out square root of 2, then this will be 7 over 2 plus 2x and minus x squared. Now this is something that we can now complete the square on. Probably the easiest thing to first of all do is to write that denominator as 13 over root 2, and then we've got 1 over the square root of 7 over 2. Then I'm going to write it as minus of x squared minus 2x dx, and then I can complete the square on this part here. Well, that will give me 13 over square root of 2, and then inside we've got 1 over the square root of, have 7 over 2, then completing the square, minus x minus 1 all squared, and then minus 1. So that when we take that minus of minus 1, that's going to give us 9 over 2, and hence you can see that we get the expression that we're asked to in the question. So let's just go through that again on a nice neat slide. There it is. So we took out the 13 and a factor of 2 from the expression in the denominator, which of course becomes root 2. Leaving us with something that we can complete the square on, and then when we've manipulated that we end up with 9 over 2 minus x minus 1 squared. So this is now inside the square root looking like the a squared minus x squared that we require for the standard integral. Well, one way to evaluate this would be to use a substitution. Let's say u is equal to x minus 1, and therefore du by dx is equal to 1, so that this becomes the integral of 13 over root 2, and then we've got the integral of 1 over square root of 9 over 2 minus u squared du. So using the standard integral, this becomes 13 over root 2 arc sine. Then we've got x over a, where a is equal to 3 over root 2, so therefore we've got u over a, which will be u root 2 over 3, and that of course will be plus constant c. Then substituting back into the expression for u, we get that our integral will therefore be equal to 13 over root 2 and then arc sine of x minus 1 multiplied by root 2 over 3 plus c. So you can see that in this particular case then we've used the substitution x minus 1, and that gave us an expression here where we could use the standard integral, because we know that a here is equal to 3 over root 2, and therefore we get u over a, so u root 2 over 3, and substituting back in. Because we've got du by dx is equal to 1 here, it would be possible to do this by direct comparison with our standard integral. So looking at the final answer, you can see that here we've just got x minus 1. So it's just a straight substitution there of x minus 1 in the answer. Everything else is just the same, a being equal to 3 over root 2. So this is now x minus 1 over a, or root 2 x minus 1 over 3. In summary then, we need to take out factors in the numerator to make sure that the numerator is equal to 1, and coefficients to give us 1x squared in the square root in the numerator. Once we've done that, then completing the square and the remaining expression will give a expression that we can then use substitution for to apply the standard integral. It's possible with practice to miss out stages 3 and 5 by doing the thing by inspection. However, I would suggest that you do plenty of them by using substitution method before you try to do that. Well, that concludes this video on using arc sine. In the next one, we'll be looking at similar techniques using this time arc tan x.